today I'm going to teach you how to use this mole map in order to convert from grams of one substance to grams of another substance. The mole map at first looks complicated, and it's really not. What's important is to convert whatever grams that you have into moles, and then using the mole ratio from the balanced chemical equation, you can convert to moles of something else because you have that mole ratio. Then once you're in moles of something else, you can convert to grams. So we'll talk about the mole map, and we'll use it in just a minute. So first things first, it's very important to start with a balanced equation. Well, if you look at this, it's not balanced. Right away you see, well, there's 4 carbons here, it's not balanced. So we need to balance this chemical equation. I'm going to balance the equation by doubling my first carbon. I know that when I do that, this side's going to work out. So I put a 2 coefficient of 2 right here. Then I start balancing everything based on that. So 2 times 4 gives me 8 carbons. So I go on this side and put in 8, which balances my carbons. Okay, there's that. 2 times 10, 20 hydrogens. I go over here and I balance the hydrogens. What number times 2 gives me 20? Well, that's 10. Last thing is I count up all the oxygens in the product because hopefully they'll be divisible by 2. So 8 times 2 is 16 oxygens. 16 oxygens plus 10 oxygens is 26 oxygens. Okay? In order to make this 26, what number would I have to use to multiply by 2? Well, 13 times 2 will give me 26. So we now have the balanced equation that we can use to convert from grams of one thing to grams of something else. You start by boxing, you're given 14 grams of butane. When 14 grams of butane is burned, how many grams of carbon dioxide is produced? Well, that's what I'm looking for. I'm looking for grams of carbon dioxide. So I circle my unknown. I start by writing my given, 14 grams of butane, C4H10. Okay? So once I have grams, I'm going to show you the mole map. Once I have grams, let's say I have grams of butane right here. What do I need to do next? Well, I follow the map. Okay, the arrow is pointing this way to go to moles. I need to convert to moles. The only way that I can go from moles of one thing to moles of another is to use the mole ratio. You know, I use this mole troll here. He says, well, what's the password? You have to get from moles of butane in this case to moles of carbon dioxide. The password is always mole ratio. That's something that you get from the balanced equation. So if we start here with a certain number of grams of butane and follow the arrow to moles, I'm going to put 1 mole over the molar mass in order to calculate or get moles. So I just go down that unit. You put grams of butane right there. And I know, using my mole map, that I'm going to use 1 mole over the molar mass in order to get moles of A. So I do 1 mole of A, which in this case is butane, and I need to put it over the molar mass. Well, in order to calculate a molar mass, I use my periodic table. The molar mass of carbon is 12.011, and there were how many? There were 4 of them. So 12.011 times 4. That gives me my carbon. Well, I also need, 10 hydrogens. So I go back here to my periodic table. Molar mass of hydrogen is 1.008, and there were 10 of them. So I add these 2 numbers together, to get the molar mass of butane, 58.124 grams per mole. 58.124 grams. Okay, look what I did. I just go down my unit. That cancels out my grams of butane. I now have moles. So I have moles of A. I went grams to moles. I have moles of A. Well, I don't want moles of butane. I need to convert that into moles of carbon dioxide. So what's the password? The password is mole ratio. So let's see how we put that in here. I just go down my unit. That helps, okay, because it keeps you on track. It keeps you from making a mistake. Always write your units and your label. Okay, so I need to use the mole ratio. I need to use the mole ratio of what I want, which is carbon dioxide, to what I already have, moles of butane. So I go back to my balanced equation. There are 2 moles of butane, and there are 8 moles of carbon dioxide. So when I cancel moles, look, I've got moles of carbon dioxide. I've not got grams yet, but I'm awfully close at this point. Once I have given the password to the molecule, I've got moles of B, in this case carbon dioxide. So then I follow the map. Okay, it's a mole map for a reason. It gives you direction. So I follow the mole map. The arrow is pointing this way. To get to grams of carbon dioxide, I'm going to have to put the molar mass over 1 mole. Okay, what's on the arrow gives you your conversion factor. Okay, so molar mass over 1 mole. Molar mass of what? Molar mass of carbon dioxide. We are really close. So just go down the unit. Okay, now I need grams of carbon dioxide. Well, I've got mole, 1 mole. And if you recall, 1 mole of anything is equal to its molar mass in grams. Well, that's awfully convenient. 1 mole of carbon dioxide is going to be its molar mass in grams. So we go and find the molar mass of CO2. Back to the periodic table. Wow, let's see, carbon, right there. There's 1 carbon in carbon dioxide, so 12.011 times 1. And then we have 2 oxygens. There, how about that? You can see that. Molar mass of oxygen, 15.999 times 2. Last thing, add those together to get the whole molar mass for carbon dioxide, 12.011 plus 31.998. Okay, the molar mass of carbon dioxide, 44.009 grams. So I go over here and I put 44.009 grams of CO2 in 1 mole of CO2. Actually, grams should have gone there, but you know what? It's fine. So moles of CO2 cancel. We're done with moles. And now we've got grams. Look what we did. We went grams of butane, and we divided by molar mass. We put 1 mole over molar mass. That gave me moles of butane. I used the mole ratio because that is the password to get past the mole troll on the bridge. So the mole ratio, 8 moles of carbon dioxide to 2 moles of butane. Once we got moles of carbon dioxide, I follow the mole map, and I put molar mass over 1 mole for carbon dioxide, and I'll have grams. Beautiful. So I follow the mole map, so now I get to do math. Math is my favorite. Math is not my favorite, that's a lie. Okay, 14, I'm trying to get this so that you can see all of it. So 14, I'm multiplying everything that's in the numerator. 14 times 1 times 8 times 44.009. That gives me 4929.008. That's my numerator. Okay, what's in my denominator? Let's see. 58.124 times 2 times 1. That gives me 116.248. That's in my denominator. So what now? This is easy. This is like, I don't know, 6th grade math? I don't remember. It's been so long. So I take the numerator, 4929.008, divided by, what's in the denominator? 116.248. Bam. There are 42.4 grams of CO2 that can be produced from 14 grams of butane. Okay, so this is how to use the mole map and do your answer.